have assembled a group of scientists from the natural and social side of sciences that are looking at the very interesting question of anticipating global change surprise. And the talk tonight is not directly related to that, although I think that pursuits that are along that path brought tonight's speaker to Antarctica. Dr. Stephen Warren began his academic career at Cornell, went to Harvard after that, the National Center for Atmospheric Research in Boulder, and is currently at the University of Washington in Seattle in the glaciology group. He has strong interest in snow and also an interest in clouds. He was part of our session earlier this summer on the role that clouds play in climate. So please join me in welcoming Dr. Stephen Warren.
Well, thanks for coming. Right, I'm glad to see that you're all interested in Antarctica, and I'm afraid I might disappoint some of you because in case you came to see penguins, so I wore this shirt. This is the only thing we can see because we're going to the South Pole where it's too cold for penguins, or for any other life except for artificial life. So you turn down the lights here. You've been probably noticing this picture. There's a reason why you've been looking for such a long time at this one picture. It's because this one picture represents about 98% of Antarctica. So we'll look at it a little bit longer. I have been interested in Antarctica for a long time, but it was not until February 1960 that I became interested in the idea of wintering. That was when I attended a lecture and slideshow by Paul Seipel, and his title was Man's First Winter at the South Pole. But I was slow to act on that interest. It was 8 years later, 1968, that I went for a summer to glaciology summer school, and then it was 10 years after that, 1978, when I made a career change. I realized I'd probably never get to Antarctica as a molecular biologist, and so I went for retraining in atmospheric physics and started doing work related to snow. But that work was all theoretical until I moved to University of Washington and met up with Tom Grenfell, who had a long history of field research in the polar regions, and he and I together worked out a research plan for Antarctica, and we got 3 graduate students involved: Richard Brandt and Bon Walden and Susan Harder, and each of them designed his or her own experiment and got it set up during the summer, and then left me for the winter to run their experiments and collect the data for their thesis projects. So this is the standard map of Antarctica in its normal orientation, with Greenwich meridian to the top and international date line to the bottom, the South Pole in the center. Antarctica is a continent larger than Australia, smaller than South America, and it's 98% covered with ice. The great ice sheet, which would raise the sea level by 70 meters if it would all be put into the ocean. It's about the same size as the former North American ice sheet that covered Canada, both in area and in volume. Antarctica is conveniently divided into 2 parts by this mountain range, the Transantarctic Mountains, which divides the smaller part is called West Antarctica, and the larger part is called East Antarctica, because it's mostly in the eastern longitudes. And if the ice did remove from Antarctica, East Antarctica would remain as a continent about the size of Australia. West Antarctica would just be a chain of islands. There are Antarctica's international territory. Many nations have set up research stations on the continent. Almost all of them are around the coast, where they can be reached by ship. And there are only a few in the interior. Some of them maintained for a few years, some of them summer only, and there are only two that were really maintained for a long time that were set up in the International Geophysical Year 1957, the station at South Pole, the U.S. station, and the Russian station at Vostok. Now the South Pole is the only one that's still running through the winter. Vostok shut down this year for inability to get the fuel and food in. So now we just left with this one station in the interior that is making year-round records, has been since 1957. There is another one in the interior up here. It's the Mizuho station, a Japanese station. It's only about 200 miles in from the coast. So the reason that I chose South Pole and Vostok for my work is because I'm interested in climate. And for climate, it's the large areas that count. Around the coast, it might be interesting for the glaciers and the icebergs and seals and penguins, but the climatic measurements might represent only one small valley. But at the South Pole, we could make measurements that would apply to a huge area of the Earth's surface. I guess I should show you, yes, where the other stations are. The U.S. stations are at South Pole and at McMurdo and at Palmer. Palmer is reached by ship from South America. McMurdo is the main U.S. station, and it is the access to South Pole, and it is directly south of New Zealand. So the route to South Pole goes by way of McMurdo Station, and the route to McMurdo goes by way of New Zealand. So we first go to McMurdo, where the National Science Foundation has a clothing distribution center, a clothing warehouse. And here are the cold weather clothing on display. The most important thing are the big white so-called bunny boots that are rubber on the outside and on the inside with a thick layer of felt in the middle. They're very important to keep your feet warm. So we loaded our luggage onto the airplane for an 8-hour flight to McMurdo Station over the Antarctic Ocean. These are cargo planes, and so the people just fit in wherever they can. Looking out the window, down onto the sea ice of the Ross Sea. There's clouds over the sea ice. And this is McMurdo Station. It is a Navy base, actually, which tolerates the presence of a few scientists also. And it is the largest station in all of Antarctica, with a population over 1,000 in the summer and about 200 in the winter. It is located on Ross Island, which is a volcanic island. There are two major volcanoes, Mount Erebus and Mount Terror. This is Mount Erebus, which is active, occasionally smoking. It's 13,000 feet high. This is a dusty city because it's built on these volcanic cinders, which are easily broken. And it's the farthest, it's the closest approach to the pole by ship. It's 78 degrees south, and this is the farthest that ships can reach. The sea ice actually melts away this far, usually in the summer, and at the end of the summer, the ships can come in. That's the reason that Scott chose this location for his trek to the South Pole in the early 1900s. And in fact, the major tourist attraction at McMurdo Station is Scott's Hut, built in 1902, and it's opened for visitors every Sunday afternoon from 2 to 3. Well, let's get on to the South Pole. The first step is to meet at the downtown airlines terminal to catch the bus out to the airport. And the airport is 1 hour's drive out onto the Ross Ice Shelf, where the planes are waiting, the ski planes. The U.S. Antarctic program has 6 of these planes that are flying back and forth between New Zealand and McMurdo and out onto everywhere the field camps and the South Pole. And the route goes, it's 800 miles from McMurdo to the South Pole, and the route goes over the same route that Scott took on foot across the Ross Ice Shelf and then across the Transantarctic Mountains up onto the interior plateau. So just one picture of the Transantarctic Mountains and one of the large ice streams draining East Antarctica. And this is the runway at South Pole Station. This plane lands on skis. It can land either on wheels or on skis. So it's got the wheels that can be lowered if it's going to New Zealand. The station is now supplied only by airplane, and whereas the Russian station is supplied by tractor train, and the South Pole was at one time experiencing a few tractor trains, but it's entirely supplied by airplanes now, and there's a flying season which is 3.5 months, from the 1st of November to middle of February. 100 flights come in to bring people and cargo and food and fuel. The fuel that's necessary to keep the station operating through the winter and through the summer, that requires half of those flights. There are 45, something like that, flights just for fuel alone. There's the fuel hose to harvest the fuel out of the airplane. So, who is it that welcomes you to the South Pole? The United States welcomes you to the South Pole. And it is right there at the South Pole. This is the pole. It's marked by a copper pipe with an American flag. And this is where all the longitude lines meet. Here are the markers showing this is the Greenwich meridian, 0 degrees. This is 180. This is 90 east and 90 west. However, the ice is flowing slowly. It's flowing about 10 meters per year. So every year in January, the Geological Survey sends down 2 surveyors to relocate the pole and to set a new copper pipe. So now if you look back, there's a string of copper pipes going off into the distance so they gradually get buried by the snow. The snow falls only about this much in a year, but eventually they get covered. So this, well, that's the pole for this year. And a short distance away from the true pole is the ceremonial pole. So as not to disturb the true pole. And it's surrounded by the flags of all the nations that originally signed the Antarctic Treaty in 1961. Most of the buildings at South Pole are enclosed under these protective structures which keep the wind off, this geodesic dome and this long archway. And first we'll look under the archway. Half of this archway is used just to store fuel, which is stored in these 9 large bladders, which at the time I took this picture were mostly empty. It was in December, but by February they were bulging full with enough fuel to last through the winter. Then we go into the dome. The dome isn't heated inside just to keep the wind and the snow off the buildings. And there are several buildings inside inside the dome. There's this is science labs and offices in the bottom, and sleeping berths on the top. Here's some more sleeping berths. In this building, it's radio room, communications down below, and library upstairs. And this is the kitchen and dining room, and then the bar and photographic darkroom upstairs, and a couple of small buildings. This is a greenhouse that was just established a couple years ago, and this is the firefighter's shack. And it's quite comfortable, actually. Nice, pleasant dining room, even when there's 140 people. Somehow, I guess not all of them eat in the dining room, but there's still still space available. The storage space, well, the frozen food is stored outside along the inner wall of the dome. And we were able to grow just a small amount. We could grow some lettuce and a few cucumbers in the greenhouse and one tomato. That tomato was auctioned off with a raffle. The trouble with the greenhouse, this problem has since been fixed, but it has to be humid, warm and humid in the greenhouse, so that frost collects around the door and became difficult to open and close. There is a store, actually it was a combination store and post office at the South Pole. Post office even has a zip code. As you can see, there's quite a crowd here at the store, and the reason that it seems to be so popular is that the opening hours are rather limited. It's open from every Monday, Wednesday, Friday from 7 to 7:15. Where you can buy your postcards and T-shirts and photographic film. This was my office, just the entrance to my office, my filing cabinet on the outside. And the office didn't have any windows, so just to remind myself what was outside, I had to put that first picture up on the wall there that you've already seen. Oh, and my bedroom for the winter. As the winter went on and I tore the pictures off the calendar every month, then my walls got more and more decorated with pictures from continents other than Antarctica. I guess the telephone's unplugged. I didn't want to get any phone calls. And in the summer, we could spread out a bit more. Move out into the so-called summer camp, which consists of 9 of these Jamesway huts, these half cylinders, rather inefficient for fuel consumption, but nice because they're spacious and have windows, and you're closer to the environment there. I set myself up with a little corner with a bed and some shelves for the summer. And our group of 5 was fairly large, so we were assigned one of these temporary outside buildings, which we named the Palms. Out at the upwind end of the station is this building is called the Clean Air Facility for atmosphere. It's built on stilts, so it 1987. And so I would say the most important person from the point of view of our safety, the most important person at the station was our power plant mechanic, Bill Getz, who, if those generators don't run, then we for sure all freeze to death. Bill was from Montana and had worked previously in Alaska in the mining camps and had spent a winter at McMurdo Station as a power plant operator, and then he came for a winter at South Pole. Okay, now it's time to change the tray, I guess. Is that right? Oh, okay. Chores. Well, volunteers sign up for chores if they have time. For Sunday cooking, the cook's day off is Sunday. For checking the power plant, the generator, and everything has to be checked every 2 hours throughout the day, throughout the year. And water runs, meaning to go out and fetch snow for the melter. This is a water run, driving a Caterpillar tractor out to this area, which is a designated clean area, the so-called snow mine, to scoop up the snow in a bucket and bring it back, dump it in the melter at the power plant. Oh, another chore, this just is to remind me of a chore, then is snow shoveling. We had blizzards. Blizzards about a third of the time in the winter. This is our first winter blizzard, the 8th of March. Some of these blizzards lasted for 2 weeks. And the particles are very fine, and they go everywhere. And we had the entrance to the dome is this tunnel. We had some doors that could be closed, but and maybe better turn on the autofocus if you can find it. But there was a little gap under the doors so that the blowing snow could actually come in and build up these snow drifts inside. Okay, I'll just show you a few pictures about some of the science projects. I made heavy use of this tower, 23-meter tower. We did some experiments that required the tower, collecting snow up on the top and also looking at reflection of sunlight. It's a walk-up tower, has a stairway, so it's easy to get up and down. One of our experiments was to measure the reflection of sunlight by the snow and how it varied with angle. This was in support of a project to try to develop a method of measuring ozone from satellites using visible channels on satellites. And the biggest difficulty with that is knowing the pattern of reflected radiation from the snow, because the satellite only looks from one angle and doesn't measure the average reflected radiation. So we're measuring that and how it was affected by these snow dunes that roughen the surface. So we have this probe that the light comes in, this probe set on an angle setting device so we could look at all different angles, and the light comes in through an aperture and goes through the fiber optics guide to our photometer, which is housed in this insulated heated box that there's electrical power on the tower. So we had a light bulb that was controlled by a thermostat to keep the box warm, to keep our instrument warm. And it worked down to temperatures of minus 65 Celsius, or minus 85 Fahrenheit, I guess that is. Another use of the tower was to collect snow. We wanted to go high enough to be above the blowing snow so we could collect snow just as it fell and do the chemical analysis on that snow, and then later sample the snow on the ground to see how its chemistry was altered after it had fallen. So one of our samples was this what we call the windsock collector. It would rotate around to face the wind, and you can see it's collected a fair amount of snow. Now, what do we do for entertainment at South Pole? Well, every Sunday we had a lecture like this for an hour. And another source of entertainment was volunteering to cook on so, Pam, are you doing you want to? If you can do it, go ahead. I won't mess with the focus if you want to do it. Let's see what else. Oh, and then there's the race around the world. This is held once a Okay. It's a foot race around the world. It's actually around the airport taxiway, which encloses the pole. So it's 3 times around the taxiway, so that means 3 times around the world. Most everybody participated, and there's most people running, others on skis. And the winning time was, I only took 37 minutes. I was the slowest, actually came in last. And he thought maybe I was stopped. 72 times. The reason is that I think that when you're world, it's better to go slow because it's also possible to. There's a few mountain bikes at South Pole Station, so you can even bicycle around the world. And a camp out at the South Pole. This is a summer camp out, right by the pole there. There it is, that copper pipe is the pole. The American flag's been gone, but it's been set up with a geological survey benchmark. So for 7 hours I was the southernmost person on Earth. And it's even possible to camp out in the winter, but more difficult. We had to fill up the tent with lots of sleeping bags and foam pads and mattresses and etc. So that it was filled more than halfway to the top. There's the pole again. Okay, well, that was summer and winter. Now we're getting to winter entertainment. The winter is somewhat quieter. This is a typical Saturday evening in the dining room. Okay, so now I'll show you some pictures of the environment. Really all we have is the sky and the snow, so I'll show you some pictures of the sky. The most common cloud are cirrus clouds, of course, the ice clouds. But in the summer, we also have some clouds of liquid water, some stratocumulus clouds and stratus clouds. And these clouds the temperatures are 20 to 30 degrees below freezing, but the liquid water droplets can remain unfrozen if they're very pure. So we do get liquid water clouds in the summer. And the crystals that form when these clouds precipitate are fairly large by comparison to what comes the rest of the year. These are about 1 millimeter long. The length here is about 1 millimeter. These would be called snow grains. They look like little pellets if you see them. By contrast, these pictures taken through a microscope. The blowing snow in that blizzard, these are the particles. They're 5 to 30 microns in diameter. Distance from here to here is 1 millimeter. And, there's a nice long one. Yeah, 1 millimeter long and 10 microns wide. And then a very common situation in the winter, and also fairly common in the summer, is these nice, well-formed ice crystals, so-called diamond dust. and they might be only 10 microns or less across in the wintertime, although much thicker in the summer. So they're very small. Compared to one of these crystals, it would take 1 million of these crystals to make a big fluffy snowflake that we're used to up here in the humid north. So, surprisingly, you might think, one of the things that some of our winterers express is, what do you miss the most? They miss snow. Because what we have is this diamond dust. This is what it looks like when we're in the diamond dust. You look up and you see the blue sky, but you look horizontally, you can see that we're actually in a cloud. We're actually in a cirrus cloud, technically, right at the surface. And this is the situation. These kind of well-formed diamond dust crystals are what can form these beautiful halos around the sun and the moon. And here's a wide-angle picture of a halo complex. This is the 22-degree halo, which is quite common. You'll see that here in Colorado, too, if you don't mind looking close to the sun. And then this is the upper tangent arc and the circumzenith arc, and then there's the parhelic circle. And occasionally, we would see, once only, we saw this very rare halo, the parhelic circle going all the way around. This point is opposite the sun, same elevation. And then there's this cross, and there's even halos here. So this is one of the attractions of the Antarctic plateau. Well, let's get on with the year. Let's get the winter started. We were visited on closing day, the 15th of February, by representatives from National Science Foundation, who told us all how brave we were and wished us well for the winter. And we all listened attentively, and then went outside to say goodbye to the remnants of the summer population, and wave goodbye to the airplane, the last plane till end of October, 8.5 months. No more outgoing mail till October. Okay, now it's time to get to work. So here I am, dressed up, properly dressed, to go up for an hour to work on the tower, carrying the data logger, which I'm going to plug in, and collect some data. But this is the finished product you're seeing there now. Now I'll show you the raw materials. So I'll start with one set of long underwear, and then a second set of long underwear, then shirt and pants and socks, and bunny boots. Now this is what I would normally wear inside. Not that it was cold, but just so that I didn't have to take on and off so many clothes when I went outside. So this is indoor wear. Then to go outside, a neck gaiter, sort of covering my lower face, and a cap and goggles, and thin gloves, and wool mittens, and heavy overknits. And now with that, I'm prepared to go outside for about 5 minutes. And that was what I would wear if I was just going from the dome out to the clean air facility. It only took about 5 minutes to walk that distance. And I would be quite cold by the time I got there because the jacket's fairly thin. But that was okay for 5 minutes to go outside like that. But for a longer trip, to spend an hour up on the tower, or half an hour, required more clothes, 2 pairs of long underwear, but also those thick down pants in the background and wing pants to cover them. So we'll put the down pants on, and they're really puffy. And made by Eddie Bauer back when Eddie Bauer used to make heavy down clothing. And then I had these special boots, these what I call moon boots, that had they're fairly light. They're mostly air, but with foam and closed cell foam. And then these little chemical toe heaters that that I would tape onto the bottom of my socks. Those are very useful. Since those have been invented, it's made a lot more possible out cold in the winter. Okay. What next? Overpants to keep out the wind, and headgear, not just one face mask, but two, or sorry, not just one balaclava, but two wool ones, and goggles, and a jacket, and a heavy down jacket, and mittens, not just mittens, but also chemical hand warmers, one for the hand, but another one for the thumb, and then this thing, which was to discharge my static electricity that I generated walking up the tower, that would go to my wrist, and then I would clamp into the tower and get a shock so that I wouldn't, when I touched the data logger with my thumb through the mittens, I wouldn't zap the electronics. That's important as well. Okay, so now, I think I'm ready to go out. But the trouble is it took so long to get ready that it's already dark outside. Well, on occasion we went out for longer to go out to dig the snow pits and collect snow samples. It took about 3 hours, but that was what we limited ourselves to. And then we did another trip a couple days later for 3 hours. And the difficulty is that on a long trip that the breath condenser will freezes onto the goggles, so you can't see. So there's a real temptation to take off the goggles. And I did that sometimes. And fortunately, eyes are apparently very resistant to frostbite. And it just doesn't apparently happen that eyeballs get frosted, which is fortunate because we did take off our goggles a lot in the winter. However, after the sun came up, that was no longer an option when the ozone is down to 111 Dobson units, and we had to worry not just about the cold, but also about the ultraviolet light damage to our eyes. Now the difficulty is that the nose protrudes and allows a gap for the air, the breath to come up there and get onto the goggles. So one solution, not the best one, but the one I happen to have a picture of, is to just tape that hole shut with adhesive tape, and that works. Then the goggles don't light up. Okay, well now I'll just go through a sequence of pictures through the course of the winter. This is in March as the sun is approaching the horizon. It's going to set on the March equinox. At the South Pole, the sun doesn't rise and set during the day, it just goes round and round, and so it just gradually declines as it moves north and south with the seasons. And just a few days before the equinox, I open the shutter every half hour to get the sun as it moves around the horizon, right to left. And then a few days later, it's down a bit lower, and then finally on the equinox, it's right down on the horizon. So that's sunset, a very leisurely sunset. And then after the sunset, for about a week or so, several weeks actually, we're seeing, here's the Earth's shadow, this dark band, and above it, where it's sort of pink, that probably is scattering by the Pinatubo aerosol. This was 1992, and there was a lot of volcanic aerosol in the stratosphere. Well, it gets darker, but we do have the moon. The moon is up for about 2 weeks, then it sets for 2 weeks. And it's in its larger phases during the winter because its smaller phases are when it's over by the sun, but that's when it's below the horizon because the sun's below the horizon. If you want to think about that. at the end of April, it's really quite dark already for several weeks, but we had this amazing sight of a sunlit cloud, which we only saw this once during the whole winter. This is the so-called noctilucent cloud. It is about at 80 kilometers. Yeah, about 80 kilometers up, so, and about 5 degrees latitude north of us, so that it is still sunlit, even though the sun has long ago set on us. Well, halfway through the winter, in June, just near the June solstice, an airplane came. This is scheduled every year. An airplane flies down from New Zealand and doesn't land anywhere. It has to be refueled in the air from another plane, a tanker plane that flies along in the Antarctic Ocean. It drops parachutes with carrying bundles of supplies and mail at McMurdo Station and then at South Pole, or it does, if it can, if it can see the drop zone so that it doesn't drop everything through the dome. So that day we were in the midst of a 2-week blizzard at that time, but we prepared for the airdrop. These are the tractors. There are 3 tractors poised for the recovery to go out and find all the bundles that parachuted down out of the dark sky. And we found all of them, all 18 bundles, brought in the parachutes to hung them up to dry in the gym. And then comes the job of sorting the mail. Christmas decorations were put up. Christmas in June. And not just mail, but also bananas, and pineapples, and watermelons, and even eggs that were very well packed individually in foam, so they wouldn't break when they crashed down into the snow. And magazines, the first magazines in 4 months. Okay, well, that was June, then there was July and August, and the twilight starts returning. And then finally, at the September equinox, the return of the